Okay, we're back and we're ready to do number 4. So let's see what we can do with number 4. Alright. So number 4 says a person who has trouble with navigation experiencing the following displacements. So he goes 4 kilometers east. Alright, so I'm not going to bother drawing a sketch. I just know those are all nice north, south, east, west. So I'm going to say here's my x's. Here's my y's. 4 kilometers east is a positive. And then this lucky soul goes 6 kilometers north, so that's still positive. And then he heads 1 kilometer west. And then he heads south 5 kilometers. So that's going to be a positive 1 there, and a positive 3 there. So his displacement is going to look like a triangle that is 3 kilometers on the x-axis and 1 kilometer on the y. And you're going to pretend that that's a right angle. So here's his resultant displacement. And there's his theta. So r is going to be the square root of 1 kilometer squared plus 9 kilometers squared. I believe that's the square root of 10. And if you take the square root of 10, you're going to get 3 points. Let's see, what do we have? Well, what's up with that? So did I do these wrong? Because I'm not getting the same answer that I got on my worksheet. So let's go back and look. Alright, so he had 3 kilometers east. Oh, duh. Should have been a 3 right here. My apologies. So that's going to be 2 there. And I think that's right, 2 and 1. Yeah, buddy. Alright, so this should have been something a little bit better than what Miss Walker did. 2 kilometers and 1 kilometer. So there's my resultant. So r is going to be the square root of 2 kilometers squared plus 1 kilometer. My apologies. So that's going to be the square root of 5. And the square root of 5, now that I've got it going on, is 2.24 kilometers. Now I need this theta, where the 2 tails are. That's the theta I need. So I'm going to say tan theta is equal to 1 kilometer over 2 kilometers. And if I did that correctly, theta is going to be 26.6 degrees. That's Pilot's bearing, which is a perfectly acceptable answer. I could also call it 26.6 degrees north of east, which is totally acceptable as well. If I wanted to, I could call it 63.4 degrees east of north. Now that last 63.4 I did in my head, so if you get a calculator and find out that it's wrong, it's all good. I tried. Okay, so there's number 4. Okay, let's go with some black ink and do number 5. Number 5 says that a rock is resting on the ground. 2 recalcitrant 4-year-olds decide that today is not the day to share. They both begin to pull on the rock at the same time. So here's my rock. Frank, who has eaten his Wheaties for years, pulls to the south with a force of 50 newtons. So there's Frank. Joshua, who dines regularly on T-bone steaks, pulls on a bearing of 37 degrees. So here's Joshua, and his force is 30 newtons, so it's a little bit too long. We're going to get rid of some of that. There we go. 30 newtons, 37 degrees. So they want to know what is the resulting force. All right. So if I draw my little parallelogram, I'm looking basically for that diagonal right there. Well, let's do better now. Don't have any right angles, so I'm going to play with my XY chart. So this little sweetheart right here, who happens to be named Frank, he's pulling straight down. He has no X component, so he's a minus 50. Okay, this dude right here has a Y and an X. And if that's a bearing of 37, then this is going to be 53 degrees. So I'm going to say that cosine of 53 degrees times 30 newtons is the y component. And when I did that, I got, you see, cosine of 37 degrees plus 30 newtons for the y. I got 18.05. Cosine of 37 degrees times 30 newtons. No, I'm lying to you. It's 23.9. Okay, cosine of 53, sine of 37, same thing. So that should have been 18.05, which is what I tried to tell you all. Now I want to do the sine of 53 degrees times 30 newtons. And that's my x. And so my sine of 33 degrees is the same thing as my cosine of 37. So that's about 24 newtons is my x. Okay, so this y is a positive 18.05. And this x is a positive 24. I'm going to add up the x's and the y's. So when I do that, I get 24 newtons on the x and 31.95 newtons on the y. So it's a negative 31.95. So now I'm going to draw my right triangle. So there's my 24. And there's my negative 31. I just ignore the negative sign, 31.95. So here's the r. Well, it's in the quadrant we said it should be. It's down and to the right, so everything looks pretty darn good so far. So r is going to be the square root of 24 newtons squared plus 31.95 newtons squared. So if I do that math correctly, which I seem to be struggling with, but I think we're on it, it'll be 39.94 newtons. Now I need this theta. Remember, it's where the two tails come together. So tan theta is equal to the side opposite, 31.95, over the adjacent, 24. Theta was going to wind up being 53.13 degrees, and that's going to be south of east. If I didn't want to do it that way, I could say 360 minus the 53.13, and that would be pilot's bearing, and if I did it that way, I'd get 306.87. So that's an option. If I didn't want to do it that way, I could find this angle here. So if that's 53.13, this one's going to be 36.87. And I would call that east of south. So you got lots of options. All right, how in the world did I get that? Well, this is 53.13. We just proved that. This is the right angle. So 90 minus that 53.13 is where I got the 36.87. So that's 36.87. If I want to get to this diagonal, I have to go to the east, head toward the east of south. I'm going away from the south and headed toward the east. When I say I'm headed east of south. All right, let's see what number 6 holds in store for us. I'm sure it's going to be quite fun. Okay, number 6 says, there are two forces on an object. Force 1 acts in a direction of 90 degrees with a magnitude of 20 newtons. So this is number 6, 20 newtons. That's a funky looking end, isn't it? Okay, and then force 2 acts at a direction of 180 with a magnitude of 30. So that looks really nice, but these are not head to tail. So I'm going to pick this one up and slide it. And now I know that this is a hypotenuse that I want. That'll be my resultant force. And I should have made it a dashed line like I asked you to do. So close enough to a dashed line. So that's R. This is still my 20 newtons. There's my theta, because I always want it where the two tails come together. So R is going to be the square root of 20 newtons squared plus 30 newtons squared. So if I did 20 newtons squared and 30 newtons squared, when I did that, I got 36.06 newtons. So there's my resultant force. Now I need my theta. So tan theta is equal to the side opposite over the adjacent. So when I did that, theta wound up being 34 degrees. So I can say that's 34 degrees north of west. Or I could say that it's 56 degrees west of north. Or I could say that 180 minus 34 would give me a pilot's bearing of 146. So there's the pilot's bearing, west of north, north of west. I don't care. You pick and choose whichever one you like the best. Surely one of those three you can find one that you prefer. All right, now let's see what number 7 has in store for us. You have the forces shown, blah, blah, blah. So when I did it graphically, I got 136. And I measured with my protractor, and I got 35 degrees north of west. So you try that and see what you get. Okay, then I had to do it with components. So my X and my Y. Well, if I look at force 1, it's 80 newtons and it's to the right. And there's no Y. If I look at force 2, it's 100 newtons. Pilot's bearing is 45 degrees. So here's my X. Here's my Y. So using sine and cosine, I would get 70.71 for the X and 70.71 for the Y, and they're both positive because that vector is in quadrant 1. And then I said, well, here is force 3. It's got a bearing of 150 newtons, 150 degrees. It is 110 newtons. This angle right here is 30 degrees. So X and Y. So when I did sine of 30 times 110 newtons, I got 55. This is kind of, I think, identical to the one we did in class. When I did cosine of 30 times 110, I think I got a negative 95.26, and it's negative because it's pointing to the left. Oops, that's supposed to be an N for newtons. And then the last one that I needed to do was F4, and F4 was 200 degrees at 160 newtons. So if it's 200 degrees, 160 newtons, here's my X, and here's my Y. And this pilot's bearing for this axis would be 180, 20 degree angle right there to get to 200. So when I did cosine of 20 times 160, that gave me my X. My X wound up being a negative 150.36. And my Y wound up being a negative 54.7. Now I'm going to add them up. And when I did that, I got negative 94.91 here. And that's in newtons. And this one came out to be a 71.01. Now I'm ready to draw my right triangle. So negative 94.9 and a positive 71.01. Pythagorean theorem. When I did that, I got R to be 118.53. And theta, tan theta, is equal to 94.9 over my, I'm sorry, that's not right. Let me do that again. Tan theta is equal to 71 over 94.9. So when I did that, I believe I should have come out with about 36 degrees. And that would have been 36 degrees north of west. And that is incredibly close to what I got for, alright, let me see if I can find the little, what I got for the other one. So I'm looking pretty darn good. Good luck.